everything ready at this repository, github.com/peter/smith2/RxJS example. So anything asynchronous means there is a code that gets read, interpreted, and run that has a response later in the execution. So part of the history of being asynchronous has been callbacks. So a callback is a basic part of JavaScript that says, given an event happens, once it happens, execute this function. Here we have the definition of a function called request listener. Inside of it, we call some data, and it's based on this.response text, and then we log it. We have another one called error, which is going to log out an error. And then on lines 10, here we create a new XML HTTP request. Then we say on load, do this certain bit, on error, do some other certain bit, and then open up the request and send it. So we could quickly modify this to pull a real API and see what happens. So to do that, we can go to JSON placeholder and get a fast API GET request. So doing this one here is going to yield us a user from, oh, of course I can make the font bigger. So I don't know how to zoom in on the URL, but just know that this is the response from the URL that was given. So we have this response of a user ID, etc. And I'll open up the inspect on here and then open up the console. I'll do a quick bit on this gist to edit this GET request to be that same URL that I had from before. Copy paste all of this, put it in here, press enter. It refuses to connect, and that might be a course thing. That's a sad state of affairs. I don't know that I'll be able to get around that, and with that in mind, I'll think about a alternative. And for the moment, we'll try to understand. Let's see if I can do placeholder JSON cores. Simple. I'm not sure. Nothing good coming from that. Nothing good coming from that. Moving forward, the callback method is sort of the very first way that anybody ever did asynchronous stuff in JavaScript. After that came promises. Who here has used promises intentionally? Okay. And who here has ever used promises at all for anything? Okay. So it's about the same there. A promise is a simplification and a new API to do asynchronous work. Now, asynchronous work is possible to happen from any number of ways. A common one is for API calls in the browser or on Node. The general idea is that you need some data from another website, and then you want to, once that server responds, do something with it. So in the first case with callbacks, you would do that with a callback function. With promises, you still technically use callback functions, but they work in a different way. So if you're looking at the screen right now and you're seeing this fetch function, it has this .then, and a promise is a promise because it is thenable. Thenable means that you can call .then on it. There's no hidden mystery to it. It's just a matter of definition. So when you see .then, you're working with a promise, and .catch is a way to catch errors in a promise. First problem with callbacks was that they got messy. The second problem that callbacks had, I suppose, would have been that error handling was even messier once you wanted to do that. So you'd be handling success cases and you'd be handling error cases. And then promises come along, they can flatten out a lot of nested callbacks. You can do this, then that, and then this, and then that. And you can use promises inside of promises. I'll modify this example just briefly. You could do, look at this and think that we would say this data.json, we'll pretend that this is a cat API. I like that idea. This is an API for a cat. Here's our cats. Our data.json is going to return all of our cats and yes. I can do both of those things, absolutely. I can answer what is an API and answer what is asynchronous. Continuing forward for this part here, we can call fetch and return it and do something that looks like API cats to make that a little cleaner, do okay. What is an API? An API is a way for two programs to talk to each other. You're not writing JavaScript to do something manually. You're doing it to do it pragmatically. So when you want your JavaScript program to talk to anything else, an API is what you do in order to achieve that. Having an API does not necessarily mean that you're going to use the web. Programs themselves have APIs. Fetch here is a part of the basic JavaScript API and the browser APIs. A promise is another form of API. So what's commonly thrown around when we're talking about APIs is RESTful APIs. And a RESTful API is anything that is fetching from another place on the web that adheres to certain standards set out and known as REST. And note that when something's looking like /API and then cats, tends to be RESTful. There's another competitor out there. We could talk about two different competitors. One which is more dated called SOAP, one which is more modern called GraphQL. Yet if you look at both of them, you'll see that SOAP is on its way out and GraphQL hasn't quite taken off. RESTful APIs dominate the web. Everywhere you go, you'll find yourself a REST API. If you don't, you're likely to see it in the future if it's SOAP or it's something that is also available in parallel to a GraphQL API. Now with that said, all APIs that are RESTful have this implicit asynchronous part to them. They don't respond immediately. They don't execute immediately. When we look at this code here as I add it, and I say const x equals 1, we don't wait for anything if we want to do console dir 1. With a REST API, if we said const cats equals this fetch bit, and then we console dir'd cats, there's a problem here. The data hasn't come back by the time that we called console dir. So asynchronous means the opposite of synchronous. This here is synchronous code. This is just going to execute, no problem. I'll do an inspect, and you're going to get what you think you would get, 1. When I run this one here, it's not going to work, and it's going to throw an error, and I'll be curious to see which one it is. So it's a good one. It's that what you've got back is a promise. Now, it synchronously creates a promise, but a promise is what it sounds like. It is an agreement that at some point in the future, your data will be available. So how do you access that code? Is through a .then function. Now, I'll speed into this point that I was making at the beginning about promises, which is that you can use a promise to return a promise. The first thing that we're doing here is calling an API that gets all the cats. Then we're taking as a argument to that then function, a new function. Forgetting the semantics of it, we're first getting all these cats in the form of raw data. We're then synchronously keeping them, and we're saying, these are cats. We're pulling off from the array of cats that came back the first cat, and then we're using the API to get the single first cat. Now, we can do more stuff with it. We can say data again, and we can say const cat is equal to data.json, and so on and so forth forever and ever and ever, as many thens as we want to do. Raise your hand if you never used promises. Okay. What about this makes no sense?
Cats.
Okay.
I don't know what a cat is, but I see it everywhere, so I'm not sure. It's obviously relevant, but I don't know what it has to do with.
Got it. And for you, Ed?
Same thing, yeah.
Okay. It's just an arbitrary animal that we're using to make a point about fetch API.
But what would the end result of that be if you ran that string of code? What would I be looking for?
Is it a variable?
Okay. I got you. You want to make a website, and you want it to show cats, and you want to get those cats from the cat database.
Okay.
To get access to that cat database, the cat database has an API. So this line 7 is making a call to that API that says, get all the cats that are in the database. From that point, we need to wait a little bit. We don't know how long it takes the server to respond. We'll figure it's a fast one, and it's going to be 300 milliseconds. Even so, we still need to wait that 300 milliseconds. JavaScript can handle asynchronous bits, and this is what will happen. This will run immediately, and we could do something down here like console log loading. So we would say get the cats, and then the next thing that you would see is this. But then later on, once those cats came back, we would be seeing and doing this. Does that make sense?
JavaScript is non-long. It will just keep going.
Okay. Where are we at with the general concept of this is going to happen after this? Are you with me there? Okay. That's the key bit. That's what asynchronous is. Even though we've written it in a line, we can use this part after this 8 through 12 after 20. That's all asynchronous means. It means forget the order that we wrote the code. We can write the code in an order that has, we can execute it out of order from which we wrote it. So the next thing that we did after we called and we got all the cats is we made a new call, which is just going to get us one cat. We want to get more details on it. We figure out what they all are, and now we just want one. And then we can do stuff with it. I don't know what, put it out on the screen. It's sort of arbitrary. So that's promises. What promises can't do very well are take in a stream of data and output a stream of data, which is something that's more and more common in the world. And what it exists to help us with that is called RxJS. RxJS is going to make streams of data that are asynchronous. We know what asynchronous means. It means it's kind of going to happen later. What a stream means is it's going to happen consistently. Thinking about a stream is one of the hardest things that I've ever done in programming. This is absolutely the most challenging part about understanding when you're new. It's something that is also new to the world as a programming concept. It's called reactive programming as a style. It's been more and more popular, but because it's not as well written about as object-oriented programming, as functional programming, the whole world is still figuring out how to describe what's going on. So it's not straightforward to start, yet there is a click point, and then you feel really, really cool, and you can do some really cool stuff. So I'll jump now into RxJS as a thought on how to handle API responses, and then we'll go into some of the other stuff. So now everybody can go to their RxJS browser window and follow along. Everything that I'm showing here is an example of responding to an API call, and it's doing it by RxJS, and these are all RxJS operators, and the language around create an effect is not very important to you. And with that in mind, I'll start to explain it. And let's, instead of my asking after each example what y'all think and understand, which I would say is probably minimal because it's just not intuitive from the beginning, I'll run through all the 5 or 6 examples that I have here, and then speed along to example 8, which is the playground, and then we can all start to mess around with RxJS and get our hands on it. So, example 1, map, switch map, and the custom operator of type. Of type was an RxJS operator that is not written by the RxJS team. I'll say that again. There's a team called RxJS developers. They make operators for RxJS, and of type was not made by them. It was made by another third party. RxJS allows you to write custom operators. RxJS gives you and works with streams of data. If you've ever written any jQuery, let's see, who's written any jQuery in your life? Cool. You've written your jQuery, and if you had a variable that had some jQuery magic on it, you prefixed it with a $sign. Does that sound about right? All right. With observables, you append a $sign at the end as a common practice. Not everybody does it. Observables are not required to have that $sign. It's meant to give you that helping hint like jQuery does, or like you did with your jQuery variables. So login is a stream. Actions is a stream. Every observable stream has this .pipe function. Now, if we're thinking about rivers, we might as well think about plumbing and think about water flow. Your observables are your plumbing, and you can set up a pipe. And each turn in the pipe is an operator. Each operator does something to redirect data and make something happen. Switch map is an operator that will return an observable and give you the response that that observable emits. We'll know here that in the response to an action called getUser, we're going to call an API service and get the current user. And once that returns data, we're going to map that user to a new action called getUserComplete. Now, if we're thinking about any asynchronous action or any call to any server or API, we've just described a very basic need for any API. Make a call to get a user, fire off that HTTP request, and then respond to it. This is very similar to the then, but it looks different. Before we were saying, I want some cats, then make the API call, and then do something with the cats. Example 2, catching an error. Here we have the of type operator, which is listening for the action called validate login. We do the same switch map as we did before, but now we've got one pipe on top and another pipe below. The reason we do the pipe from the switch map here is because this sub pipe is going to not interfere with the running of the rest of this program. So if the switch map were to error out and a new validate login action were to happen, this whole action stream would still be alive. If we had it flat and we caught the error and handled it, then the action stream would end up erroring out. Example 3, with latest from, filter, and switch map. The stream of actions is a single stream of action data coming in, and we have another stream called store. So we can use with latest from operator to take the one stream of data, which is going to have some data from this of type operator, combine it with the latest from the store, and then what we get is an array which has that action and the store. And in this filter function, we're going to use both of those bits to say if the action's expense ID is equal to some piece of data from the state, then continue with the stream. And then we do this switch map and we go forward. Example 4, retry. We have a action of type save photo complete. Once the save photo happens, then we want to call an API to get the receipt, and we pipe a retry operator. So when the get one receipt fails, we can retry. By passing no arguments to retry, this will retry forever. When it's successful, this will continue to go and then map to a get expense data complete action. Example 5, retry when, delay, and scan. Here, similar to the other one, save photo complete happens, we do a switch map, and we're just calling the API get one receipt. We're going to then retry when, which will occur on errors. We get an error stream back, which will then be piping the delay operator to delay 2,000 milliseconds or 2 seconds. Then we pass it the scan operator, which is going to try 10 times to make a receipt call, and after 10 times of failing, it'll throw an error. Then below, it'll catch that error and it'll handle it. Otherwise, if it was successful, we'll map that data. So I'm going to pause on this one here.
This is essentially Java 8 languages, JavaScript, pretty much.
Well, good. That's good.
Yeah.
This one here is achieving some complex functionality without a whole lot of code. Now, anybody who's gotten more on the advanced side of JavaScript has to do this at some point, which is to make an API call, and if it fails, try again. The first thing you do with RxJS is make an API call in this particular framework. It's just a straightforward way to handle it. And when you start to work with it more and more and more, this code here, while it has this depth to it, it makes a lot of sense. It begins to sink in what your operator options are, and there's hundreds. There's a lot of operator options. You don't use all of them all the time. You can see that switch map is a common one in this use case, and so is map. And you can understand that filter works very similar to the filter array operator. Same with map operating in the same way. Yet, with promises, you don't have that extensibility. To retry a promise is a one-time deal. But with a observable, when you're one-time, every API call is a one-time deal. Let's start with that. Every API call is just going to be make the call, and it either succeeds or it fails. Yet, if you have that as a part of observables, you can kind of pull another API call if it fails. And you can keep pulling it until it succeeds, and then you can move forward and do some things. So you can kind of go back up the stream and down the stream. And that's not something that's possible with promises, and that is the big success of RxJS in the context of APIs.
So example 1, you're creating this reference, login dollar, is that observable?
Please ask that again.
Is login dollar in example 1 an observable? What is that an instance of?
Good question. Also not going to be covered here. It's something that's easy for us to cover later on after going through some more examples. Let's look at the example 6 here. You can all click this link. You'll get to a JS bin, and you'll see a totally different use case for observables. I'm clicking out of the HTML, and I'm clicking out of the CSS, and I'm only showing the JavaScript and the output. So I'm going to zoom in and just show the JavaScript. The first thing we're doing is we're assigning this observable from the Rx package, and then we're assigning the from event. We're doing some basic JavaScript stuff to get a canvas element, and we're getting the context of it. And it's at the point later where we're defining points and outer radius, etc. We're just getting some elements by ID. And then here, we start into this observable, and what we're doing from event. This is another way to create an observable. It's creating an observable from an event. Looking at what points is, it is in the HTML, if we see it, it's an input. It's a range input that's got a minimum of 3 and a maximum of 7 and a starting value of 5. So when we look at the JavaScript and we read it, we can see that we're going to get that input when there is an input event, then pull off the target value, and we're going to start with the starting value of points. For each and every single input on the screen, we do the identical bit, and then we call combine latest and subscribe to it, and then we apply our draw function. The output, the result of all that code, is that we have this shape, which when we adjust the slider is going to adjust the shape. So we're now looking at another source of asynchronous events. Users. It's not just servers that we're not sure when they're going to respond. It's also, we don't know when a user is going to take action on our page. Could happen at any time. They could press the button, they could choose the color, they could ultimately take any action on any input, and then we need to respond to it. So we're generating some observables to handle that. And it's a stream of data. All this user input is happening not just once, but again, every time we change a input, we are adding to that stream of data.
Is there any debouncing going on with it?
If there's any debouncing happening, the question is, where is it happening? And because there is a debounce operator in the observable package, it's very clear to see if that's happening, where that's happening, and when that's happening. And you can look on my screen now and we can do some debounce because it's not happening currently. And the way we can do that is to look at this combine latest, and we can add in a dot debounce. And if I'm remembering the API right, then we can debounce with adding in a number of milliseconds, and now we've done it. That's how you add in a debounce into a stream. Call the debounce operator, and then add in how many milliseconds you want to debounce by. Same thing with throttle if you wanted to do that too. Let me bump up some of the size here and show that little bit of edit that I just did. Dot throttle, dot debounce. All right, let's look at our output. And appears that I had an error, and it could be because of the incorrect usage of the debounce API. Yep, it might be debounce time, and I'll give that a shot. And in case that doesn't work immediately, we'll move on and understand that it is possible to do. It's just that as we are here live, it's not clear exactly the way to get it done. So I'll refresh the screen, go to debounce time and see that that's still not working. All right. Moving forward, GitHub, Peter B. Smith, RxJS examples. GitHub search. This is an example from another repository. It doesn't run as cleanly in the browser. Anybody's free to git clone it, and we'll do that after we finish up with all the 8 examples. But I'll show you what it looks like, and we'll talk about it for a second. Can run dev server. Run from localhost 8000. Localhost 8080 could be what it's really coming from. Yep. Okay, I'll search for RxJS. And now I got some data. Is there anybody here who doesn't understand that this is asynchronous? Is it clear to everybody that this is asynchronous? When I type in the name of something, I'll type in React, and then it does a little load, and now I've got some React data. We're looking at an example from GitHub. If I type in another one called Vue, now it's going to do some asynchronous stuff, and it's going to be Vue. Okay. I'm going to mouse over the Vue logo, and then we got a little bit more data. I'm going to mouse over the Vue or whatever logo this is here, and there's a little bit more data. So there's 2 async things that this little app is doing. We're typing in the word React, and then we're getting a list of GitHubs that have React in their name. Then we're mousing over a logo, and we're getting a little bit more detail on that specific project. Okay. Everybody remembers the cat example? What did we do? We first got a whole list of cats, and then once we had the list of cat, we got a little bit more data on just one cat. It's a very common pattern to get a whole list of stuff and then get more data on one thing. This is what this app is doing. It's getting a list of stuff, and then it's getting more data on the singular one. So let's look at the way that this code is running. I'll open it up. I'll go to the source. I'll go to the JavaScript, and I'll go to the index.js. First thing that you see is we import Rx, and we've got a couple of helper files, and we've got this CSS. We've got jQuery running here, so we've got our jQuery prefixed bits. And we've also got some observables here, and rather than adding in $signs, we have the word observable to indicate it. So we're debouncing 500 milliseconds. We're doing a take while, which is to say, for as long as this condition is true, then continue to do the next bits. We are generating this from an event, and it's a mouse over on the avatar. So we just remembered that we moused over the logo of the project, and then some things happened, and now we're seeing exactly what that means. First thing, when mouse over happens, do a debounce of 500 milliseconds. This take while is for as long as you're moused over it, and CSS is being used to have a addition or subtraction of these classes. So the next thing that we're going to do is map. We're going to return some data. Then we're going to filter, and then we're going to do this flat map latest. I'm not going to focus on what that means exactly, but I'll look at what this get user function is doing. It's from this helper file. We look in that helper file. We look at get user, and we see we have a promise, and we're generating an observable from this promise. It's a common thing to do. And once we have that promise returned, then we can continue to work with that in the stream. The get user promise is going to be a API call. Yeah, what value do you get out of turning a promise into an observable, given that the data only resolves once? By having this getUser function return an observable, much like a promise can return a promise and operate with a dot then and a dot then and a dot then, you can do the same with observables. So in this case in particular, flat map latest is going to use that promise, which only happens once, in this broader and bigger stream. So now we can make that API call every time that somebody does this mouse over in a very straightforward way, and have it operate with the rest of our observable pipe. So the value isn't so much in having a promise turn into an observable and then starting a stream there. In this case, it's having a promise turn into an observable and having it operate in the existing stream. Okay. And then .do is no longer active in the latest versions of RxJS, but it is what is known as a side effect operator, and anything that you want to do that doesn't have anything to do with later on in the stream, you just want it to happen, you can do in a .do. And in the latest versions, it's a tap. Okay. Final example is going to be the playground. Let's see. Okay. Observables can be used in a lot of situations. We saw drawing one before. Here, observables are listening to mouse events and moving Mario. It's using canvas, etc. A smart counter, smooth transitions, numbers with ease. Let's write in the number 5. Write in the number 10. I don't know what happened there. Let's write in the number 10,000. Now we're counting up. We make this bigger. I'm writing in the number 10,000, and now we are counting up to 10,000. I'll change that to 750. We'll update it, and it stops at 750. Observables are managing all of that. There is some stream of events that are happening after we press the update button. It's happening using the data from this input, and it's taking into an account when to stop based on that input. If I change it down to 100, now it's counting down and doing the same thing. And if I can get to it in time, when I change it to 500, it continues to count down and it stops at 500. Showing another example called animation. I move around my mouse. Here's another stream of events and things that are happening in response to it. Crop. We've got an image. We can click and move these corners. Let's go to mouse tracking. Hold down mouse button while moving to see the coordinates. So in response to clicking, we're outputting data on the screen to show the X, Y. We can do infinite scroll. Every time we have a scroll, let's load some more data and then do some more scrolling. We can do a type ahead when we type a name like Joker. We get a list of data. I'll show that one more time. Joker, then we get a list of data. You can go to ally and you can find out ally. Let's do a debt calculator. Interest rate is 5%, number of years is 3. Anytime we change one of these inputs, it's recalculating our total debt. We want to borrow $10,000. We've got 75% interest over 3 years. It costs and has a debt of $32,500. Let's look at data binding. First name is Peter, last name is Smith. Then our form data is currently Peter Smith as being the output. Let's look at common and not do that one because that's not real. Let's look at drag and drop. We want to click this, drag it around. It's a click event, and then we're having a piece of HTML move around in response to it. Let's look at something called dynamic render. Here's that same example as we had before with the shapes, where we're having the canvas update to the inputs. We can go to follow the mouse, and then the mouse, its tail is happy. So as we go through this, who has any thoughts that RxJS is going to limit your ability to do work in the browser? Or who has thoughts that RxJS is going to open up you to new possibilities of programming interactive and reactive things? That is the question. That's RxJS.